Here we're going to look at example 4 from topic 1, operations with rational and irrational numbers. So question A, and this is kind of jumbled up a lot, but just bear with me. This is a lot like the last example where we're just going to go through some theory and adding and multiplying rational and irrational numbers and determining what the outcome is, could not be, is always, is never, things like that. So question A, is the sum of a rational number and an irrational number rational or irrational? So to figure this out, what we want to do is, if we can write the sum of an irrational and irrational number as a rational number, you could write the following. So what they're saying is that AB is rational, and if we add that irrational C, whatever our answer gets, whatever we get as our answer, if it's rational, it can be written as P over Q. Okay, so that's kind of this is the assumption we're making, and we want to see if we can prove this to be true or false. So right here, they state AB is rational, right? It's written as a fraction. C is irrational, and PQ is rational. What they're doing next, and they're skipping some steps here, but they're taking this and they're converting it to isolate C. So what they did is, just bear with me here, they're subtracting AB from each side. So they get C is equal to P over Q minus A over B. And then what they're doing from there is they're combining P over Q minus A over B by finding a common denominator, which would be BQ. And then this, again, it's kind of jumbled up here, but they're saying that C would be equal to PB minus AQ over BQ. And this is important later on. We wouldn't really realize that that's the first thing we should do, but as this problem goes through, you'll see why they did that. But these two steps here, this step and this step, is what they did not show, and kind of be filled in the blank in between those two steps there. So just be aware of that. All right, so let's jump here. In the irrational numbers above, A, B, P, and Q are integers. We talked about this in the last example. If we're dealing with rational numbers, those numbers are going to have to be integers. And our denominators, P and Q, cannot be equal to 0 because that would cancel out the fact that they are rational numbers. This means that PB minus AQ, so our numerator, is an integer. Right? And we talked about this last step where if we had a bunch of integers and we started working on combining them, they're going to stay as integers. And that BQ is an integer and cannot be equal to 0. So that's our denominator. Again, we talked about this in the example where since B and Q were not 0, then BQ also cannot be equal to 0. So what that tells us is this whole piece here, this BP minus AQ over BQ, is a rational number. Actually, of all integers. So if it's all integers, it should be a rational number. However, we were making the assumption that C was equal to this. So BP minus AQ over BQ. And we were assuming that this number is irrational, right? C was irrational. And we now know that this piece here is rational. But if they're equal to each other, how can an irrational number possibly be equal to a rational number, right? One single number can't be both irrational and rational. It's one or the other. So can the number be both rational and irrational? No, it cannot. So what happens here is this doesn't work out. So what went wrong? The mistake was to assume that you can write the sum A over B plus C in the form P over Q. So what we can't do is that if we have a rational and an irrational number, and sorry for all this highlighting here, hopefully you're able to follow along this. If we're adding a rational and irrational number, it's impossible for it to come out as a rational number. So we can then make this statement here that the sum of a rational number and an irrational number is always an irrational number. All right, and this was all the work behind it. Hopefully you kind of grasp that. It might take a couple times through the video or reading through this example a couple times before you really fully grasp that, but you'll get it. All right, and again, we're looking for the idea of when we're adding and subtracting these numbers, what's going on there. Part B is the product of a rational number and an irrational number, rational or irrational. This is quite like what we just did in example 3 and then in part 4a. So is the product of a rational number and an irrational number rational or irrational? So we're going to write the product as a rational number, which is what we did before, right? Oops. So up here, we did AB plus C equals P over Q. So rational plus irrational equals rational. What we're doing now is we're doing rational, right? Rational times irrational and is equal to rational. They're doing the same thing. They're bringing this AB, they're dividing by it, they're bringing it over to the other side, and that's how they're getting this piece here. Okay, so I'm not going to write all that out again, but they're just isolating C. To do so, you would multiply by B over A, which is going to get you this. Okay, so keep that in mind. So let's take a look at what we have now. As in part A, C is both rational and irrational. So here, we know that this is irrational. But here, if we're multiplying these integers, we know A and B and P and Q are both rational. And we talked about this last example in example 3. A rational times a rational is going to give us a rational number. So if these are both rational, or sorry, if the right side is rational, the left side is irrational, we run into the same problem. So a number can't be both irrational and rational. So the assumption that we made, this here, is wrong. All right, we can't make that assumption, or we can make the assumption, but we've clearly proved that it's wrong. So we also want to notice that in order to divide by A, when we're calculating C, you have to assume that A is not equal to 0. And what happens in the original equation if A is equal to 0? Well, if A is equal to 0, then A over B is equal to 0. And if A over B times C would then also be equal for any number C. So we can't have that. All right, so just kind of, again, keep that in the back of your mind. But the main thing we're looking for here is that the product of a rational number and an irrational number is always rational, unless, all right, and this is a big unless the rational number and the product is 0. All right, so if we had the 0 in A or B, that rational number, not A and B, if A was the number 0, then this kind of gets canceled out, and that wouldn't work. But that's the only exception. Product of a rational number and an irrational number is always rational. Okay, but like math, a lot of times there will be an unless, okay? Unless the rational number and the product is 0. Hopefully that didn't drive you too crazy. I know, again, it's a lot of theory. It's a lot to get thrown at you early on in the school year, but just have an idea of what goes on when you're adding and adding and multiplying rational and irrational numbers.